the linear programming computer solutions. So before, if you remember, the discussions or lectures that I shared with you last time is the linear programming problems where we solve them manually. Okay, so you draw in the graphic paper, and then of course we solve the x, for example, the value of our variables mathematically using our mathematical equations. But this time, we're going to make use of the computer solutions like our Excel and other applications that are available. Okay, so if you remember, these are the results that we had in our previous examples. Okay, so if you actually didn't watch those videos, then you might not be able to follow how we come up with this linear programming model. Okay, because this linear programming model are what we're going to use as the starting point for this discussion. All right, and then as we use the computer applications, we should be able to get the same results. Right. Okay, so linear programming tools. So just remember that in linear programming problems, we solve them using the what we so-called simplex method. So even before, when there were still no computers and all these tools available, the mathematical procedure that is being used is the simplex method. So I'm not going to discuss the meaning and all these things about simplex method, but later on, it is important that we know about the simplex method, because when we use the solutions, let's say the Excel, we have to make sure that we choose the simplex method, okay? If we are actually solving linear programming problems, okay? And this time, that is what we're gonna do. So again, what we need are Excel, okay? And then we need to install the quantitative functions or features in Excel. And later on, we're also going to discuss the quantitative method for Windows. Okay, so this is actually one application or software that's available in the market, and that is one that is most commonly known when it comes to quantitative method. So we're going to discuss this separately. For now, let's focus on Excel. Okay, and by the way, when it comes to Excel, of course, we need to have the offline Excel. If we are using the Google Sheets, so definitely we can use that. But as I said, we will also need the applications or features in addition, okay, to the formula that is available in the spreadsheet. So, and that application is called Solver, okay? In Excel, it is just named as Solver. If you use the Google Sheets, you have to install it from the add-ons. You have to have it in the add-ons, okay? So you're seeing my screen now, right? So in the add-ons, you should see the solver somewhere here. So if you don't have it yet, like I do, I still don't have it. So we get the add-ons from the Google Play Store. And that is from the search, we type solver. Okay, and we have here a few options. Actually, just two. Solver, optimization for Google Sheets, and another one, open solver for Google Sheets. Okay, so you choose which one will work for you. You install and see if these applications will give you the right results or solve the problem well for you. Because for others who download, okay, let's say the solver, for others that download this, it doesn't work for them. But for others, it works for them, right? And the same case with this one, Open Solver for Google Sheets. So you choose which one will work for you if you're going to use the Google Sheets. So I'm not going to download it now. If you are using WPS, okay, WPS Office, you're going to find the solver under Data, okay, and What If Analysis. So if you click on What If Analysis, we have the solver here. If you click on that, okay, this is how it looks like. Okay, so where we are going to input our data. So Google Sheets WPS and even Microsoft Excel, they have the same parameters, okay, or requirements for this if you're going to use the solver. Okay, because solver is one of our options in calculating our variables in a fast way. Okay, so that's it. And then for Microsoft Excel, okay, you should also, so I already have the data here, for example, later on. So you should find the solver under data also, and here is the solver. Okay, we have here the solver. Now, it is possible that you don't see the solver in your Microsoft Excel because it is not a default function. So if you still don't have it, so we have to add it, okay, as an add-in. So how do we do it? We go to File, and then Options, and then under Options, we go to Add-ins. From here, we should see here Solver Add-in, okay? And we have to make sure that here under the Manage, we have here Excel Add-ins because we have other options here, okay? So you have to make sure it is Excel Add-ins, and then you hit Go. And then here we have 4 options of add-ins. You have to make sure that the solver add-in is marked with check. Once you mark that with check, click OK, and you should see the solver in your Microsoft Excel. Okay, so later on we're going to use this one, okay, as one easy way to solve our problem. Okay, so that's it. By the way, if you're using smartphones, unfortunately, the solver cannot be added in the spreadsheet application or in the Excel application in smartphone. So they are just basic features that are in the spreadsheet applications in the smartphones. Now, however, there are other solver, linear programming solver applications, so separate applications in the Play Store. So you can just search for linear programming solver, okay, and maybe look for that for the different options there, and then you choose which one also will show what we really would like to use. Okay, so later as we discuss, you should have idea of how these solver applications will be used. Okay, so let's start now. Again, so let me go back to my slides. So first we will start with Excel. Okay, so let's use the first problem as that we had last time, which is the Beaver Creek Pottery Company. Okay, and the Beaver Creek Pottery Company has this. Okay, what happened? Okay, so has this situation. All right, and with the requirements given in the problem, we came up with this linear programming model. Okay, so it's the same way as we determine or we come up with a linear programming model. So of course, that's what we're gonna do this time. It's just when it comes to solving the variables, the x1, the x2, okay, things like this, and also the maximized profit. So it's just we're gonna use the Excel this time instead of computing them using the mathematical equation and also using the graphic papers for the graphs, okay, and all these things. So this is our problem, okay, or linear programming model, wherein our goal is to maximize our profit, which is equals to $40 of x1, that is the number of bowls to produce, plus $50 of x2, the number of mugs to produce. So these coefficients, okay, the 40 and 50, we call them coefficients. They are our profit per unit, right? So here. And our objective function is subject to our constraints. So first constraint that we have is the x1 plus 2x2 is less than or equal to 40 hours of labor. And then for the clay, it's 4x1 plus 3x2 is less than or equal to 120 pounds of clay. And then our non-negativity constraints are x1 and x2 are greater than or equal to 0. Okay? Okay, so all right. So using the manual computation, we came up with this graph. So as we uh, solve this problem using our computer solutions, we should be able to get the same. So let's move to our Excel. So this is our Excel wherein I have already prepared our table, okay, for our linear programming model. So here we have to have the columns for our variables. So in this case, we have x1 and x2, which represents bowl and mug. Okay, and then we have our total column for the total usage of our resources. And this one is also includes our total profit here. And then we have our constraint equation column, which will be our guide. And then our available or maximum resources column. And then our slack variable column. Okay? So, by the way, for this, you see here LHS, and then RHS. LHS means left-hand side. That is left side of this equation or this inequality function, okay, left side. And this one is right-hand side, okay, the right side of our inequality or equality function. So we're gonna see this abbreviations when we use the solver function and get the reports. And even though if we use the other softwares, they usually use the LHS and RHS terms. So for our data, okay, we put here the coefficients. Okay, so first the number of units to produce. This is our variables. Okay, so this is the x1 and x2. So I have highlighted it in yellow, and we should know that this is or these are the cells that we need to find, okay, that we need to compute, or our solver will need to calculate for us. And then our profit, so we have the coefficient of 40 and 50 for x1 and x2 respectively. We have the labor coefficients of 1 and 2 and clay of 4 and 3. Okay, for the total of our left-hand side, so of course when it comes to profit, we know that it should be calculated as the profit per unit times our number of units to produce. So it should be this, okay, I am highlighting it, times this. So basically, that is the product of our number of units to produce and our profit per unit. Now, what we usually know, maybe, is we compute this manually, like, you know, one by one. For example, this one times this one, and then plus this one times this one. Okay, and then we get the product. Okay, so but if we actually have a lot of items to multiply, then it will take you some time, you know, to multiply each of the cell. So one easy function in Excel is that we use the sum product, okay, and that is the sum product function, which is we multiply our multiplier and our multiplicand. Okay, that is those are the arrays. What are the items that we're gonna multiply? So first array is our, let's say this one, we're going to multiply it with the profit. Okay, that is our second array. And you see also here with the word sum, because the good thing about this is you can multiply, you know, let's say if we need to add the products of two set of numbers, so, you know, Excel will do it for us, right? We don't have to type in plus, plus, plus. So you just use some product, and then the first multiplier Okay, set or array 1, and then comma, and then the second set of the items or cells that you need to multiply. So we should be able to get the same number here. So we have the same formula for labor and clay. It's just the labor, okay, the coefficients for labor and then the coefficients for clay are the ones changing. Now, we can actually just retype our formula here in the total for labor and also clay. But if you have a lot, again, a lot of, let's say, constraints, items to multiply, then it will take some time from you. So the easiest way is just to copy the formula, okay, from, let's say, here. We already have one for profit. We just copy it to labor and clay. Either you Control-C and Control-V, or you just drag it down here. So the thing is, we know that, you see here the formula, we know that our formula should have this, number of units to produce times our labor per unit. And then for clay, it's number of units to produce times our clay. Okay? You might notice here that I have here a dollar sign. Okay? In between C and 3, D and 3. Okay? What does it mean? So when you put a dollar sign before, let's say, the row number, or let's say the column number, so actually we can also put dollar sign here, okay, or both. So the meaning of that is we do not want that cell to move or to change as we copy that same formula to the other cells. Okay, so we want these cells to be fixed in our formula. Okay, that's why in here, when we copy the formula here, okay, we see that, you know, this row 3, okay, C3 and D3 remain the same. Okay, see, they did not move. So we get the correct formula in this case. However, for example, let me just remove the dollar sign here. Okay, if we don't have the dollar sign here and we copy the formula, okay, let's say all the way down, okay, it immediately produces some number here, a product. And the reason is, you see that the arrays have been changed. So we're correct when it comes to the labor, okay, but it's now multiplied to the profit per unit instead of the number of units to produce. Okay, the same with this in clay. Okay, we are correct when it comes to the coefficients for clay, array, okay, for clay, but when it comes to the another items that we need to multiply, it's now changed to labor instead of the number of units to produce. Now, if you do not know the use of the dollar sign, what you will do is to move them one by one like this, right? But again, if you have a lot to change and edit, it will again take you some time. So that's why we use the dollar sign for the cells that we do not want to move, okay, when we copy them to the other cells. So we will still get the correct formula. Okay, so that's just few tips. So let's move on to our main topic. So now we have already set this, okay? By the way, so we have here the right-hand side. That is, of course, our right-hand side of the equation, which is 14,120 for our constraints. And then for the slack variable, we learned that this is the difference of our total available resources and total used resources. So this is available resources minus our total used resources. Our right-hand side minus our left-hand side. So it's still 40 and 120 respectively because we still don't use any resources here. It's still 0 here. So that's why it's equal to 40 and 120 here. Okay. So this is it. Now we're ready to solve our variables. So again, in solving our linear programming problems using Excel, we have actually two ways. Okay. One is to use the solver, and the other one is to use the function, the formula, one of the formulas available in Excel. And that is the matrix multiplication. So let's use first the solver, okay? And let's see how easy it is to use the solver. So when we use the solver, we click on solver, okay? Sorry, I already have some data here. Let me just delete it quickly. Okay, so I can show you. All right. So first is the set objective. What is set objective? When it comes to objective, this is actually this one. Okay, what do we want? It is to maximize our profit, to find out our maximized profit. So let me just move it a little bit. So this is our profit and this is our total profit, right? So we want to find this, our maximized profit. So we just click that so that we get the cell, the number of cell column, okay, in here. And then we choose our objective, either to maximize or to minimize. Okay, and our goal is to maximize, so we choose max. And then by changing, what do we need to change? Our variable cells. And that is the number of products to produce, the number of units to produce for bowl and mug. So we just highlight both of these two, okay, and we leave it there. Now we have our constraints. We add, okay, we're gonna add constraints. So we can do it one by one, or we can do it together. So let's do it one by one first. One by one is this time. This is where we're going to use the total left-hand side for our constraint, okay? So this is this one. This is our left-hand side for labor. And then our inequality constraint is less than or equal to. So we have to choose from here. We have less than or equal to, equal, greater than or equal to, etc. Okay, so the default here is less than or equal to, so this is already okay. And then our second constraint is the right-hand side, which is 40. Okay, and then we can click OK, or if we're done, or we can click Add if we still have one more constraint to add. So right now we don't see what we have added for labor, but it's already there. So we can just proceed to our second constraint, which is clay. Okay, so again, left-hand side, this one. And then this is less than or equal to, so this is already okay, less than or equal to, and then we also input the right-hand side. Okay, this one, 120. So since we don't have any more constraint to add, we can just click OK. And you should be able to see our two constraints here. Okay, so this is doing them separately. And actually doing, adding the constraints separately is very important to do if we have different constraints. For example, one is less than or equal to, and then the other one is greater than or equal to. Okay, but if we just actually have two subsequent inequality functions that are the same, we can just do them together. For example, so let me just add one more just for showing you, okay, but we're gonna delete that later on. So left-hand side, so we can just put them together, okay? Highlight them together here, like this. Since they have the same less than or equal to function, okay? And so it's okay. And then our right-hand side is 40 and 120. So of course, we're going to highlight them together also, okay? And then click OK, okay? So you see here, in this one long formula here, we have, it is E5 to E6. Okay, so meaning there are already two constraints that are added. Right, so that's it. So, but for this example, I'm going to delete this one since it will duplicate our constraints. So this is adding the constraints in the solver. So the next thing that you need to check is this one. Make unconstrained variables non-negative. You want to make this, you want to make sure that this is checked, because this is the part where we consider our non-negative constraints. You see here, x1 and x2 are greater than or equal to 0. So we have not added these constraints to our table here, since I think that is automatic for us and we don't really need to write that down. But we have to make sure that in the solver, we have to check that, okay? So that the solver will read it as that and ensure that they won't consider any negative numbers for us. Okay, so that's one. Make sure this is checked. And then for the solving method, okay, so this is what I've been telling earlier, that we have to know that in linear programming, we are using the simplex linear programming method because we have to choose that in here. So we have other options here, okay? And what we need is the simplex LP or simplex linear programming. So after that, we can just now click on solve. And let's see. Okay, you see here, it says solver found a solution. All constraints and optimality conditions are satisfied. If you look in our table, we already have here the solution, which is 24 for x1 and 8 for x2. Okay, so of course we want to keep the solver solution, so click on OK. That's it, right? So we don't have to do a lot of mathematical equations. We just need to click on the solver and make sure that that is, the data are encoded. Okay? So that is the first step. Unfortunately, even if you use solver, unfortunately, we cannot graph, make an automatic graph with solver. So we have to do the graph, manually, but in Excel. So it's still a little bit easier rather than drawing in a graphing paper. Okay, and then, so before we do the graph, let me show you first the second way of solving this 24 and 8. So this is the number that we got here. We have identified from our previous lecture that these are actually the numbers that will maximize our profit in our linear programming model. Okay, so that's it. And the second solution is a bit longer. It's mathematical in nature, just like what we did before when we did it manually, but this time we're gonna make use of the Excel function. So let's do that in a few minutes, okay? And let's have a short break.